Hello everyone, I hope you are doing well. And today is our second session on the kinematics. Okay. Now, in this session, we'll be discussing about graphs. Now, before moving forward, let me tell you, graphs are one of the most important topic, not just in physics, throughout our life. Graphs are not just applicable in physics or mathematics, or we can say biology or chemistry. Okay. Now, the graphs application is huge. It has vast application through various fields. Like if you talk about data science, graphs will be there. If you talk about finance, there will be graphs. Okay. And there are many other aspects where we are using graphs. So scientists are very much fascinated with these graphs. Not only scientists, also businessmen are using the graph, or data scientists are using graph to understand or predict the future. Now, that is like the vastness. But let's come to our topic. Today, we'll be talking about graphs in kinematics. And when we are talking about kinematics, we are talking about basically ST graph, VT graph, AT graph, or there can be S versus V graph also. That we're gonna look as we move through the session. Now, before starting, let me just introduce myself first. My name is Himanshu Rai Jan, and I've done my BTech from Birla Institute of Technology. It is one of the prestigious institute in India. You have to crack a competitive exam to enter one such college. And I told you, cracking a competitive exam, it's one of the most important thing as a student we need to do in any field we go. Whether you want to become an IITian, you want to become a doctor, you want to become, let's say, crack UPSC or become a lawyer, you need to crack CLAT, or you want to join NDA, you need to crack the exam. Okay. So everywhere in any good college, if you want to enter, there will be a competitive exam. And my teachings also help you with that. Okay. And now moving ahead, our teaching experience of 9+ years. And in those 9+ years, many students have cracked IIT and have cracked Olympiad. My methodology is very simple. I take real life examples. I connect all the concepts with those examples. In that way, you not only get the concepts, but also the application part. And this session, we will conduct both in English and Hindi. मैं हिंदी भी यूज करूंगा बीच बीच में. So we'll be having a combination of both. Now coming to today's topic, what we're gonna study in kinematics, we'll be talking about graphs, and more specifically, we'll be discussing about ST, which is displacement time graph or distance time graph. Then we're gonna talk about the velocity time graph or speed time graph, and lastly, we'll be discussing about acceleration time graph. And we will also see like if ST graph is given, how to convert it into VT graph, or let's say VT graph is given, how to convert it into ST graph. And similarly, how to convert ST graph into AT graph or AT graph into VT graph. Like this, we will check. Okay. Now, let's move with the first graph. Look here. How to analyze it. What all things we can view here. Last class, I gave you the glimpse, but today we'll dive deep. आज हम डीप डाइव करेंगे ग्राफ्स के अंदर एंड समझेंगे कि कैसे कैसे हम स्टडी कर सकते हैं. लुक हियर, द फर्स्ट वन. नाउ फर्स्ट ऑफ ऑल, whenever you see a graph, you need to check it's between what and what. So here you can see on the left side, we can see distance, which is given in meter, and its time, which is given in seconds. So it's a distance versus time graph. So this is very important. Okay. Now let's look and study this graph. Look here. So first of all, the graph is little bit curved upward. You can see here it's getting curved upward, and then it's becoming straight line, and then it is curving downward, and then it's becoming like a flat line like this. Okay. And at different points, you can see something is written. Now, how to tell whether it is accelerating, or how to tell whether speed is constant, or how to tell it's slowing down, or how to tell something is stationary? Through graph. So let's understand it. So first of all, the term that we're going to use here is slope. Slope is basically telling us the steepness of the curve. Okay. Now, it's not the angle. Last class I told you, let's say if I talk about this point A and I want to draw the tangent, it will come out to be a straight line. And you can see it's making an angle with the x-axis, let's say theta. Now this theta, is it equal to slope? No, it's not. But can we calculate slope through this theta? Yes. So there is a two difference here. Okay. So theta is not equal to slope. But can theta tell us about the slope? Absolutely yes. Okay. So this is wrong. This is not true. Many of you people have this confusion. Sir, is this angle theta equal to slope? No. But the tan theta, if I have a function tan and I apply in front of this angle theta, this will become slope. It tells us the steepness of the curve. So I hope you understand what slope represent. It represents the steepness and how to draw at each point. Take any point. Let me change the color for you. लेट्स से हम लोग ये वाला पॉइंट लेते हैं ए और या फिर लेते हैं ये बी पॉइंट सो इफ आई वांट टू ड्रॉ द स्लोप एट ए I will draw a tangent here. So the tangent will look like something like this. Let me draw once again for you. It should be a straight line just touching A, just touching A. And this thing is making angle theta. So the slope at point A will be what? It will be tan theta of this angle. Okay, that is slope. Okay, now if I compare the slope at A and B, let me draw once again for you. Look here, let's say this is B. So if I draw a line at B and if I draw a line at A, you can clearly see that the angle which B is making, it's more, right? As compared to the one which is A making. So here, tan theta B and tan theta A, this will tell me the slope. And the value of this one, slope B and slope A, which will be more. See, the steepness is more for B. So the slope value for here, B will be more. And you can see it's having more angle. So this shows that B is more steeper as compared to A. And here, if the value of the slope is more, that means its speed is more because the slope of distance time graph, the slope of distance time graph gives me what? It gives me speed. How? Look here. Pay attention. Very important. We will do for every point. Don't worry. We'll go slow. So let's say if I want to draw here, okay, you start from here, you end at here. This is the triangle it is making. Okay, this much is the distance. This height is giving me distance. Okay, this value, it's coming from here. This is distance, how much it has covered. And this much is the time taken. Okay, so that's how you solve it for the slope. This height and this much time, you will get the value of instant speed at that point. Okay, so here the value is more for the B as compared to the A, and you can see it's becoming steeper. And at this point, it's now not changing any angle. It's having a straight line. It's making throughout a straight line. Okay, the slope is not changing. It's becoming constant. So the slope is becoming constant and slope gives me what? It gives me speed. So here the speed is becoming constant. Okay. And now look at the next curve. Here you can see at each point if we draw the angle. Look here. If I draw here, so clearly you can see, let's say this is theta 1, theta 2. Theta 1 is greater than theta 2. So here at this point, let's say this is D and this is C. So here clearly at C point, the slope is bigger. Tan theta 1, tan theta 2. So tan theta 1 is greater than tan theta 2. So as it goes from here to here, it's slowing down. The speed is decreasing. The slope is decreasing. Okay. So someone is trying to stop it, or maybe you applied a brake. Getting it? So it's deaccelerating. In last class, we talked about the acceleration and deceleration. So here you can see the slope is decreasing. So that means the speed is decreasing. That means it's deaccelerating. And ultimately, you can see here, ultimately, here at this point, if I draw a slope, it's becoming parallel to x-axis. Is this clear? When it becomes parallel to x-axis, at that moment, the speed becomes zero. The speed becomes zero. And you can see it is continuing. Okay. Now, how you can check more that it's becoming zero? You can see here. At this point, the value is, let's say, 50 meter. Again, if I draw a tangent here, for this point, it's still staying 50. And at this point also, if I draw, it's staying at the same point. It's not covering anything. But for other points, as it goes up, becoming straight line, then curving down, you can see the distance is increasing. But once it reached this point, here then the value at distance is not changing. Value at distance is not changing. So this is very, very important. It's becoming zero. So here it's written stationary. Let's look at the next. It will become more clear. Look here. Now, first one, the slope was increasing, right? The slope was increasing. So here it indicates that velocity is increasing. And then it's becoming straight line. The slope is constant. That means the velocity is constant. The slope of ST, which is displacement or distance time graph, gives me what? It gives me velocity or speed. If it is displacement versus time graph, it will give me velocity. If it is distance time graph, then it will give me speed. Okay. So here at second part, you can see it's becoming straight line, slope is constant, velocity is constant. Now afterwards, it's curving down. Okay. The slope is decreasing. At that point, the velocity starts to decrease. So here you can see decreasing slope indicates decreasing velocity. And you can see at the topmost point here, when it becomes parallel to x-axis, at that point the slope is zero. Tan theta is zero. Velocity is zero. But it doesn't stop there. Then it starts to come back down. It starts to come back down. Okay. Look here. Now here the slope is decreasing. The slope is increasing, but in the negative direction. Look here. If I draw for different points, let's say if I draw for this one, this is the angle. Okay. But if I draw for this point, here you can see it's making this much angle. Okay. So here you can see the slope, it's becoming steep. So here, as it goes down, even though it's negative, but the value, the number is increasing. So as it goes down, the steepness is increasing, but in the negative direction. So the magnitude is increasing, but the direction is negative. Now, is this distance correct? Or is it wrong? Think about it. Can distance ever decrease? Once we have covered some distance, let's say 10 meter, can it become 8 meter? Can it become can it become 7 meter or 6 meter? No, it never decreases. Distance can never come down. The graph of distance time graph can never come down. It can become parallel, but it can never come down. It can either become parallel or it can go up only. Because once the distance has been covered, it's covered. It can't be decreased. So this is wrong, beta. It should be displacement. So this is very, very important. Displacement can decrease. So let's say I start from my house, go to school, and then come back to my house. My displacement is zero because my initial and final point is same. But the distance will be the length of the path which I covered from home to school and then school to home. That I have to add. That will give me distance. But for displacement, it will be 0. Okay. Now let's look at the next graph. Look here. Now this is a velocity time graph. This is what? A velocity time graph. How? Because it's written, right? Now it has different parts. So here you can see the velocity is going up on the y-axis and the time is moving ahead in the x-axis. So here you can see for the first part, this is the angle. And then for the second part, you can see the angle has increased. And then for the third part, it's becoming parallel. And then it's coming down. Then it's coming down in the graph. And then it's becoming negative. And then it's becoming again parallel, but in negative. So let's understand what's happening. So first of all, we need to understand one thing. What does the slope of VT graph gives me? What does the slope of VT graphs gives me? Anyone in the chat box can tell? Think about it. Anyone knows? Let me tell you. It gives us acceleration. It gives us acceleration. The slope of VT graph gives me what? Acceleration. Very, very important. Okay. So now pay attention for the first one. Pay attention for the first one. Here, let's say this is theta1. Here it's becoming theta2. So here you can see if you compare part 1 and part 2, theta2 is greater than theta1. So clearly this will give me the value slope of 2 is more than slope of 1. So it's more accelerating in the second part. The velocity is changing quicker in the second part. And you can see also from here it went to this point very quickly in a short period of time. Okay. So acceleration for part 2 is more as compared to part 1. The slope is more. Okay. So slope is steeper. So it's changing the value of velocity faster. Now, if you come to the third part, look here, when you come to the third part, here you can see if you draw the slope, it's parallel to x-axis, parallel to x-axis. So that is basically slope is 0. Acceleration is 0. So this is very, very important. Pay attention. Okay. Now, here it's staying constant. It's not 0. Whatever will be the value, this is there. That will be the value. But now, here you can see it's coming down. The graph is coming down. So here, if you draw the slope, it's negative. It's negative slope. It will gonna give me negative slope. And that means the acceleration is negative. It's negative. Now, one thing is very, very important. If velocity is positive and acceleration is negative, in this case, the speed will decrease. The velocity will decrease. And that's why the graph is coming down. Okay, the value is decreasing. Okay. Now, as it crosses this point, for a moment, it's here, not stopping. Okay, it's not stopping. Here it's becoming what? 0. But it's not stopping here. If it is stopping here, then the graph will gonna look like this. The red line will go like this. Okay, 0 as the time passes, but that's not happening. So here you can see what's next. It's going negative. Okay, so now it started to move in the negative direction. So here, once it went from 1 to 2, 1, then second part, it went very fast, then it becomes constant. Okay, This is acceleration, more acceleration is there. Here acceleration is 0. And then the third part, acceleration is negative. Okay, and it's more as compared to the next point. So here you can see the slope with the x-axis in the negative direction. It's less. Okay, so here in next part, the acceleration is negative, but its value has decreased as compared to this part. Here, the acceleration in the negative direction was more. But when it came to this part, the acceleration is still negative, but the magnitude has decreased. And then when it comes to the last part, here it's becoming parallel. So the here it's becoming parallel to x-axis. And when it's becoming parallel, the acceleration is 0. And that's why speed is constant, but it's in the negative direction. Okay, so this is one thing. Slope of VT graph gives us what? Acceleration. But one thing more you need to understand here. What does the area of VT graph gives me? What does the area of VT graph gives me? It gives us displacement. Okay, so here you can check one thing. In this case, the first part where the graph is above, displacement is positive. Okay, but when it went down, here it will come out to be negative displacement. So what you need to do for final displacement, you have to find the D1 and D2, the area D1 and D2, and you have to add, then you're going to get the displacement final. Okay, what is the final displacement happened? So that will be D1 plus D2. Now, why we are doing plus? Because this D2 will automatically coming out to be negative. When you're going to find this thing, this will be negative. Okay, because this value of V here, when you're going to take the height here, it will be negative V. Okay, so this D2 will coming automatically negative. So let's say D1 is 10 and D2 is minus 2. So the net will be D minus 2 equal to 8 meter. Like this it will be. Very important. Okay, so that's how you find the displacement through the VT graph. What you find the area. It's not like you add D1 and D2. Let's say D1 is 10 meter, D2 is 2 meter. And you are removing the minus sign and you find the total displacement is 10 plus 2 equal to 12. That will be wrong. Okay, that will be wrong. But if it asks you about the distance, then it will be 12. Okay, because distance can never decrease. Once it has become 10, then it comes back. Let's say it's covered 2. Distance is always positive. So 10 plus 2, 12. But when we talk about displacement is a vector quantity. You have to take this thing sign very seriously. So let's say 10 is in positive, 2 is in negative. So this will be 10 minus 2. That will be the displacement 8 meter. Okay, so displacement will be 8 meter, but the distance will be 12 meter. Now let's look at the next one. Look here. So now how to convert xt into vt and then into a. Look at the first one. How this is stationary. So this is xt graph. Let's say displacement time graph it is. You can see as the time passes, you can see there is no change here in the x value. It's staying always same. So that means the position is same. It's not changing. So that means it's at rest. When it is at rest, velocity will be 0 and acceleration will also be 0. So here the VT graph will stay 0. Okay, and the slope of this line is also 0. So that's why this will be the graph. Now, let's look at the next one. Second one, uniform. Now, why this is uniform? Look here. Uniform means the speed or the velocity is constant. Okay. Now in this case, you can see if I draw tangent at different points, it will be coming out to be a straight line always, same one. And you can see angle is staying constant. So if theta is constant, then tan theta will also be constant. And if tan theta is constant, that means slope is constant. And if slope is constant, what does slope gives? Velocity. So velocity will be constant. So here you can see this is the VT graph. It's straight line. Staying same. The value is staying, let's say 2 meter per second. It's staying same. So now if velocity is not changing, that means acceleration is what? Zero. And here you can find that way also conceptually that velocity is not changing. Acceleration will be zero. And even through graph, you can see, if I find the slope of VT graph, I know the slope of VT graphs gives me what? It gives me acceleration. So here you can see the line is parallel. The line is parallel to the x-axis. So here you can see the slope is zero. Theta is zero. Slope is zero. Tan theta will be zero. So the acceleration will be zero. So that's why this is the graph. Okay. So I hope this is clear to you. Now, let's look at the next one, the third one. This is very important. Now here you can see the graph is curving upward. Initially, the slope was less, and later on you can see the slope is becoming more. Now, what does the slope of displacement time graph gives? Slope of displacement time graph gives us the velocity, and it's becoming steeper. That means the slope is increasing. That means the velocity is increasing. Velocity is increasing. So here you can see the velocity is increasing. Okay. And this is increasing. The slope is increasing at constant rate. It's parabola. Okay. So here the velocity is increasing, but you can see it's increasing at constant rate. It's increasing at constant rate. Now here you can see if you draw the slope at each point, it will come out to be same line here, and theta will be same. So theta is same. Tan theta will also be same. That means velocity will also be same throughout. Sorry, the velocity is increasing. So the tan theta of VT graph gives us acceleration. So acceleration will be same because tan theta in this case is giving me acceleration. So the slope of VT graph gives us what? Acceleration. So here tan theta is same because theta is same, and that means acceleration is same throughout the journey. And that's why you can see it's a straight line parallel to x-axis. Okay, so acceleration is uniform here. So I hope this is clear. So now let's move on to the next one, complex one. Let's check here. So this is the corresponding graphs. Okay, so now let's check here. Look here. This starts from here, and now the displacement is going down. Correct? It's going down. It was something in the positive, now it's going down, and it became negative. And at this point, you can see the slope is becoming zero. Slope is zero for xt graph. Slope zero. And here, slope negative. And here, from this point, you can see the slope is becoming positive. So now here in this case, you can see the graph. Look here. If I take this point 2, this is the point 2. So at 2, you can see the slope is becoming 0. Slope 0 means what? Slope of xt graph gives me what? Velocity. So it's 0. So at 2 point, you can see the velocity is becoming 0. Correct? And afterwards, you can see the slope is positive. It's making positive angle with the x-axis. At each point, you can see it's becoming positive. And you can see the velocity is positive and the slope is increasing. It's becoming steeper. Look here, Pay attention. Very important. Initially, the slope was this much. Now it has become steeper. In x-axis, it has increased. It was less. Now it has increased. So you can see here the graph is increasing. The velocity is increasing here. And then you can see at this point here, now it starts to curve down. Now it starts to curve down. It's reducing. The velocity is getting reduced and ultimately it's becoming zero. So at the fourth point here, this is 1, 2, 3, 4. At this point, 4, the slope is zero. Slope is zero. That means velocity is zero. So at 4 point, it should come to the 0 point. So at 3, it has peaked. The velocity has peaked. After 3, the xt graph curved down. The slope starts to decrease. So velocity graph starts to come down. The value starts to decrease. And then at fourth point, the curve here, when we see, the curve is becoming parallel. It's becoming here parallel to the x-axis. So here slope is becoming 0. That means it's becoming 0. Here velocity. So I hope this is clear. Getting it? Now, look at the first part. Okay, from 0, 1 to 2. What is happening? Here you can see the slope is again increasing in the first part. In the first part, you can see the slope is increasing here to this point. Initially, the slope was this, then the slope is becoming steeper. So here you can see the slope is negative, but the magnitude is increasing. Okay, so when it reached the first point here, at this point, it starts to curve downward. Okay, the slope is still negative, but it starts to decrease. If you make the angle with the x-axis, it's still negative. At this point, it's still negative, but it has reduced and ultimately it's becoming 0. So the value starts to decrease. The velocity is still negative. The slope is still negative here. You can see this angle which they are making, it's still negative. And at 2, which we already talked, the slope is becoming 0 for ST graph. So that's why velocity is 0. So that's how XT gets converted to VT. Now let's see how VT gets converted to AT. This is very, very important. Pay attention. Okay. Now look here. You can see for each point, each line, the angle is constant. The angle is constant. Okay. This line, green line, if I draw an angle here, if I extend it, it's coming out to be constant. Similarly, for this one also constant. For this one also constant. So for every journey, acceleration is constant. Okay, it's not changing value. So from here to here, the slope is negative. So you can see acceleration is negative and constant. Because slope is constant, but it is negative. It is negative with the x-axis. The angle is greater than 90 degrees. Okay. And then at this point, the slope is becoming positive. And it's more slopey. Getting it? In just 2 seconds, let's say. It has gone from -3 to +3. Okay. So the value of A is huge. Okay. So for this 2 points, 1 second, second, the value of A is huge and it's positive. And then when it reached here, you can see the slope again for the VT graph, it's becoming negative. So the acceleration will become negative and it's same steeply. Just like this angle, whatever it is making, same angle this line is making, but in the negative direction. Pay attention, beta, very, very important. Look here. This, whatever angle this is making, okay, same angle this is making, correct? But you check this one. Okay, it's negative. The steepness is same. The wall is on the right and left side. Let's say if I draw a wall in between, you can see both the ladders, let's say both are equally steep, but in the opposite direction. Okay, so that's why you can see the acceleration value. Let's say this is 3, this is also 3, but in the negative direction for the last 1 second, and that's why it's becoming like this. So I hope this is clear. Okay, so that's how you convert VT into AT. Okay, now let's move on to next one. Look here, how to apply or how to draw graphs for different kind of motion which is under constant acceleration. So look here. So here you threw a ball in upward direction. You gave some velocity. So initially there is some velocity. So here you can see the velocity is not zero. You have given. But as it goes up, the velocity is decreasing at a constant rate. The slope is negative and constant. That is in this case G, negative, downward. Okay. So upward is positive, downward we have taken is negative. Through this graph, I can understand this thing that upward direction is taken as positive and downward direction as negative. Why? Because in the graph you can see here, this is positive V. Okay. And you can see the slope of VT graph. It's negative. Okay. And what does the slope gives me? Acceleration for a VT, and it's negative. So that's why downward direction, which is G in this case, is negative. Okay, and it's constant. And now this point is velocity zero. Velocity is zero for a very short period of time for a movement. That's the basically highest point. So this is highest point. And then it starts to come down. The ball starts to come down. The velocity starts to increase, but in the negative direction. Okay, so that's why this graph again went in the negative. Okay, so I hope this is clear. Very, very important. Now, coming to the position time graph, look here. So it went up. Okay, so you can see this ball is going up. The height is increasing. But you can see the slope is decreasing. Slope of ST graph. Slope of ST graph gives us what? Velocity. And in this case, you can see the slope is decreasing. Velocity is decreasing. That's what's happening. Correct. In reality, when you throw the ball up, it slows down, it reaches the highest point, then it starts to fall back. Correct. So here you can see the slope is decreasing. And at the topmost point, you can see the slope is zero. For a movement, velocity is zero. And then you can see it's coming down. Now the slope is in the negative direction. Slope of ST graph is negative and it starts to increase in the value, but in the negative direction. Okay, it's becoming more steeper. It's becoming, initially you can see this was the angle. Then you can see if I draw at this point, it's this angle. So in negative, it's becoming steeper. Okay, so the velocity is increasing in the negative direction. So that's why you can see the value is increasing in the negative side. So that's why the graph is going down. Okay, so I hope this is clear how to read the graphs, how to convert the diagram into a graph. Okay, how to check what are the positions. Okay, throughout the journey. Let's look at the next one, which is horizontal. Look here. These are two different cars, red and blue. Okay, pay attention. Very, very important. Now, the first one has a speed. Okay, the first one initially we have given some speed and then it is slowing down and then it stops. Then it stops. Getting it? It's not doing any kind of motion. So you can see here the red line. Look at the VT graph first. So you can see we have given some velocity and now it's reducing, and then it stops. Then it's not changing any position. Velocity is zero. Okay. Now look at the red graph of position. The curve is curving down, correct? The slope is decreasing. So the slope of ST graph, slope of ST graph gives us what? It gives us velocity, correct? And it's decreasing. The slope is decreasing. You can see initially it was making this angle, then it is making this angle, then it's becoming this, and then ultimately zero. So slope with the x-axis, it's reducing. So that's why the velocity is reducing. Getting it? And ultimately it's becoming zero. Now, that was the graph for the red car. But look at the blue one. Now, blue one is doing uniform motion. Uniform motion means velocity is constant. Okay, velocity is constant. So here you can see the slope of ST graph. It's constant. The slope of ST graph, it's constant. Angle is always same. Theta is always same. So slope here is constant. And what does the slope represent for the ST? That's velocity. And that's why velocity is constant. Okay. Now, if I want to draw the AT graph for this one, how it will gonna look like? Let's draw. Let's draw. Pay attention. Very important. So now let's first draw for the red one. Okay. For blue one, it's very easy. Let's draw. Let's take a different color. Let's take a green color. Or let's say we draw a green lines and use red as a for red car. Okay. Now, here you can see for VT graph, the slope is constant. Slope is constant, but is it positive or negative? It's more than 90-degree, right? So here the slope is constant, angle is constant, but it's negative. Okay, it's constant and negative. So here this is AT. So it will look like something this. Okay, it looks like this because acceleration is negative and it's constant. This is what for the red car will gonna look like. And then ultimately when it stops, the acceleration is becoming zero. So that is also very, very important. There will be one option where only this much line has been drawn. And then there will be a second option where this complete will be drawn. Because see, after stopping, its acceleration is also becoming zero. Getting it? Here you can see this is the velocity graph, right? Here the slope is zero. So don't forget to draw this part also. Okay, very important. That's the detail of the concept. Now let's look at the blue one. How the blue one will gonna look like. So here velocity is constant, acceleration zero. So the blue graph will be like this throughout, zero value. So that's how the AT graph will gonna look like. I hope this is clear. Okay. Hello Shivam, how are you? Now let's look at the next one. Okay, let's try to do some questions also. Okay, here an object starts from rest and undergoes a positive constant acceleration for 10 seconds. Undergoes positive plus constant, doesn't change, for 10 seconds. It is then continues on with constant velocity. Which of the following graph correctly describes this situation? Now what's happening? For 10 seconds, acceleration is constant. And then acceleration is becoming zero. Okay. Now let's look at a D. The D1, the acceleration is increasing. Here, then it starts to decrease. Okay, it stays sometime constant for some time and then it starts to decrease. Here you can see the acceleration keeps on increasing. Okay, the acceleration itself is changing steeply. Here you can see acceleration is decreasing, not staying constant. Here you can see again acceleration is increasing but at constant rate. But here you can see the acceleration is staying constant. So that's what we need, constant acceleration. Here the graph will again, after 10 seconds, this will be 10 seconds, and then the graph will become like this. Okay. So here the acceleration then becomes 0. Here the velocity will be constant, and acceleration will be 0. Okay, so this A will be the answer. Now let's look at the next one. Check out this one, very important. Okay, pay attention. An object starts from rest and undergoes a positive constant acceleration for 10 seconds. And it then continues on with constant velocity. Which of the following graphs correctly describes this situation? Now, this is very, very important. What's happening? The start part, constant acceleration. That means the velocity is increasing. Okay, if velocity is increasing, that means in ST graph, the slope keeps on increasing. Slope keeps on increasing. Now, and then afterwards, velocity is becoming constant, same. And that means here the slope of ST graph stays same. Okay, it should be straight line. So let me just rub it from this side because it will not be visible. Let me write down at the top. Next page, let's use the next page. So when acceleration is there, which is constant, so for velocity, it will keep on increasing, right? If acceleration is there, velocity will keep on increasing. If velocity is increasing, that means the slope of ST graph, which gives me velocity, so it will keep on increasing. So the angle will keep on increasing. So it will gonna curve upward. It will gonna curve upward. Very important. Okay. Now after 10 seconds, what's gonna happen? Velocity is constant. Why? Because acceleration is becoming 0. Now when velocity is constant, that means slope of ST graph becomes straight line. Okay, with some angle. So here, let's look at it. So here it's increasing, it's correct, but here the velocity is becoming 0. Okay, slope is 0. So this is wrong. Now let's look at this one. Here the velocity is constant. No, it should increase for the first 10 seconds. Wrong. Here you can see it's straight, then it's curving down, decreasing. No, wrong. Here it's decreasing. It should increase. The slope should increase. Wrong. Here you can see it's increasing. Okay, for 10 seconds. And then after that, it's becoming straight line. So that is the answer, option E. So I hope this is clear. Okay, you can check. This is very, very important. Now let's look at the next one. The displacement of a particle as a function of time is shown in the figure. The displacement of a particle as a function of time is shown in the figure. The figure shows that displacement. Let's look at the figure first. Look at. So what's happening? This is ST graph. Okay. And you can see the slope is decreasing. Slope is decreasing and ultimately it's becoming 0. What? Slope. Why? Because it's parallel to x-axis. Okay, very, very important. So here the speed is becoming 0. Velocity is becoming 0. And here you can see the velocity is positive, but it's decreasing. The velocity is decreasing. So that means acceleration is negative. Acceleration is negative. And ultimately, the velocity is becoming 0 and acceleration is also stopping. So let's read the options. The first one, the particle starts with certain velocity, but the motion is retarded, and finally the particle stops. So here you can see it started with some velocity, okay, and it's retarding, and ultimately it stops. So that seems to be a correct one. Let's look at the B option. We also see C, B, C, D. The velocity of the particle is constant throughout. No, it's decreasing. The slope is decreasing. So velocity is decreasing. That's wrong. Acceleration of the particle is constant throughout. Is it? No. Here it is constant for this much. But then it's becoming zero also. Getting it? Here acceleration is becoming zero. So it's not constant. Throughout the journey, it's not constant. First part it's constant, but then it's becoming zero. Which then doesn't mean it's constant. So this is also wrong. Okay. People can confuse because beta, you have to also take the last part also into consideration. Here the acceleration velocity is becoming zero. Then velocity is not coming down. Okay, it's saying zero. So acceleration is also becoming zero. So that's why this is not constant. Okay. At the end moment, it's becoming zero. So that's why it's not constant. The particle starts with constant velocity, then its motion is accelerated. It finally, the particle moves with the constant velocity. No, it's deaccelerated and then it's becoming zero. Okay. So that's why option A is only correct. I hope this is clear. Okay. Now let's move on to the next quiz. Now this is a good one. Okay. Let's see how many of you can try and solve this question. A ball is thrown vertically upward. Thrown vertically upward. That means it has been given some velocity. It's not zero. Initial velocity is not zero. Okay. Which of the following graph or graphs represent the velocity time graph of a ball during its flight? Okay. So now what's going to happen? The ball went up. For a moment at the highest point, the velocity will become zero. So initially the velocity is upward. Okay. Now in all cases, you can see the graph is starting upward. Getting it? So here you can see velocity at the start has taken in the positive direction. So upward direction is taken as positive. And then the ball comes down. The ball comes down and the velocity becomes negative. So now we have to find a graph where for the first part it's positive. Then for a moment it's becoming zero. Then it goes negative. So now here, look here. Why the first one is wrong? Because in this case, you can see time is going backward. So here you can see the arrow is going like this. So the time is going backward to zero. So time can't go backward. So this is wrong. C. Look at B. Here, okay, the velocity was given, it got decreased zero. Then the time went backward. It's not possible, right? Time always move forward. Time can't decrease. Let's say 5 seconds has passed. It will not go to 4, 3, 2, 1. So again, B is wrong. Let's look at the A one. Now here, it has started with some positive, correct? Then for a moment, it becomes zero. But it should go negative. It should go in the negative direction. But it again went in the positive. So again, this is wrong. Okay. Now let's look at a D1. Look here. It started with some value, positive. Then for a moment, it becomes zero. And then it started to go in the negative direction. And that's why D is the answer. This shows the correct one. Okay. And even though we can check, the slope is also constant. Here, slope is always constant and negative. Let me write down in a different place. Slope is always negative, always, okay, and constant. And do you know what is this slope here? Slope of VT graph is acceleration. And in this case, acceleration is minus G. Okay, very important. Okay, negative. So I hope this is clear. Why option D is correct. Let's look at the next question. Look here. An object is moving. An object is moving with a uniform acceleration which is parallel to its instantaneous direction of motion. An object is moving with a uniform acceleration, okay, and which is parallel to its instantaneous direction of motion. So let's say this is the direction of motion and same is the direction of acceleration. So the direction of V and A is same. Direction of V and A is same. That shows what? That shows that V keeps on increasing. V keeps on increasing. Okay, but acceleration is constant. Now, which of the following graph is correct for displacement versus velocity? Now, it's not displacement versus time or velocity versus time. The things have changed here. It's displacement versus speed. So here what we want to see is that velocity is increasing. Okay. So now let's say initially it was 10 meter per second. After 1 second, let's say acceleration is 10 meter per second square. After 1 second, it becomes 20 meter per second velocity, then 30, then 40, then 50. So now you can see after each second, the displacement will be changing faster. Getting it? For a 10 meter per second change in velocity, the displacement will change faster and it will become more steeper and steeper. Getting it? But here you can see the first one. Here, velocity is increasing, but the displacement is changing at the constant rate. So this is wrong. Okay. Now this graph is automatically wrong. Okay, you can see here, if velocity is in the same direction as of acceleration, so the displacement will also keep on increasing. Here you can see it's showing wrong. Okay. The velocity can never decrease. So here you can see it started to come backward after this point. Velocity can't decrease. It should increase. So this is also wrong. Look at the curve, beta. Look at this one. Here, it is in this increasing, velocity is increasing. But after this point, the velocity starts to decrease. That's wrong. Okay. Now, this is wrong. This is wrong. Now, in this case, the B case, let's check. Now, here you can see as the velocity is increasing, the displacement should increase faster. But you can see initially it was increasing faster, but slowly, it started to increase very, very slow. And then it is not changing. Even though the velocity is there and displacement is not changing. So that's wrong. Getting it? It should increase faster. Now look here, look at the C1. Here you can see initially velocity was there, displacement is changing, increasing, and now velocity is increasing. Now displacement will increase faster. So you can see it's becoming steeper. The curve is going upward. So that's why option C is correct. So I hope it is clear. As the velocity increases more and more, the displacement will increase in a faster rate. Okay, let's say it was increasing by 10 meter, then it will increase by 20 meter in 1 second, then it will increase in 30 meter in 1 second. So it will become more and more steeper, and that's why this is a curve in the upward direction. Okay, you can also do in a second method. How? This was logically through visuals. There is one more equation, right? We have this equation where v square is equal to u square plus 2as. Okay, in this case you can see the relation between here. Okay, how the s will change. If you plug the value, you make it double, let's say you make it double. Okay, 20, it becomes 400. Okay, if I make it 30, it becomes 900. So clearly it's not linear. 400 के बाद 800 नहीं हो रहा है एक second बाद. Okay, it's becoming 900. So that's why you can see it's increasing more steeply. That's how you can also solve. Now let's look at the next question. This is also an interesting one. Pay attention. A ball is dropped vertically from a height d. So there is a ball. It's dropped from a height d. Okay, above the ground, and then it hits the ground and bounce up vertically to height d2. Then it bounce back to the height d2, d by 2. Okay, and then its velocity varies with the height h above the ground is. See, when it is being dropped from d, then after the, like when it hits the ground, then it will gonna bounce back. Now if it is with the same speed, it will reach to the same height d, but it's not reaching to d, it's reaching d by 2. So the velocity has reduced because of the impact. Because of the impact, the velocity has been reduced. And now we will see the graph. Now this is a very important thing, that we are talking about velocity. We are not talking about speed. So let's say if I take downward direction as positive, if I take downward direction as positive, or let's say take downward direction as negative, for example. Okay, let's say downward direction is negative, upward is positive. So when it is falling down, velocity is increasing. V increase कर रहा है और D जो है वो reduce कर रहा है. Getting it? It was D height. Okay, and then it is reducing and becoming 0. But the velocity has increased, but in negative direction. So you can see here, this one, the D is reducing, it's going to the 0, and the velocity is increasing in the negative direction. Okay, let's look at the next one. Here, initially there is some velocity value. Here also it's some value. That's wrong. Initially can't be there. Okay, and the arrow is wrong, beta. It's showing that this is the initial point. No. Okay, so this is very, very important. This is wrong. We will check the A part later on. Now let's look at the D one. Look here. So this one, the bigger one, it's saying that the velocity has some value, and then it has some D it reached. That's wrong again. Okay. Now let's look at this one. B. It is saying that it has some velocity. No, beta, it has been dropped. Dropped means velocity should be 0. So here velocity has some value. That's again wrong. The arrow should go like this. Okay. But since we have taken the downward direction, it should be in negative direction, not in the positive direction. Okay. So again, this is wrong. Now let's look at the A one. A is the answer. Why? Let's check. So here there is some displacement, height, and downward direction is negative. Okay. So now the displacement is reducing and the velocity is increasing in the negative direction. So you can see the displacement is decreasing and the velocity is increasing in the negative. And here you can see the displacement when it hits the ground, the displacement is 0. Okay, because the height has become 0. It's with the height. Height is reducing. Getting it? Now, after it hits, the velocity direction becomes positive. It is not negative. So it starts from a positive now. Okay, and then it reaches some value d by 2. So this is d by 2. So you have to understand, beta, the direction has reversed. So for one journey, the velocity is negative, and for second journey, the velocity is positive, because initially it was going down, after hitting it is going up. Okay, so at here, this point, there is some velocity value positive. Here velocity is 0. Here it is v but negative before the bounce. So that is basically the option A happening. Okay, so I hope this is clear. Once again, I can show you. Look here, pay attention. Initially the velocity is 0. Yes. Height is d. Correct. As it is going down, the height is decreasing. It's going towards the origin, 0, and the velocity is increasing in the negative direction. As it hits, this is where the hit happened. As it hits, the velocity becomes positive. And when it becomes positive, the value is less. and then it goes to the d2 d by 2 point, and at this point it again its highest point velocity is 0, and that's why it is reaching this graph. That's why option A is correct. Now let's look at the next one. This is also very interesting. A ball is thrown vertically upward. So there is a ball, it's thrown vertically upward. Which of the following plots represent the speed time graph? Now we are talking about speed. Now speed can never be negative. Okay, speed कभी negative नहीं होती. जैसे car is moving at -50 meter per second. We can't say that. Or -60 meter per second. It's not possible. Okay. So pay attention. The graph will always be positive. Which of the following plots represent the speed time graph of the ball during its height if air resistance is ignored? Now, we know that this is motion under constant acceleration because it's under gravity. Okay, so this is very, very important. Pay attention. Okay, now look here. You can see here in the first part, slope is constant. Okay, slope is constant. But in the second part, slope is not constant. Slope of speed time graph gives us acceleration. So this is wrong. This is also wrong. Curved. Acceleration can't change. Here's the slope is changing. Here also slope is changing. Wrong. Slope should not change. Only here you can see the speed which was thrown upward. It was becoming 0 at the highest point, and then again it starts to come back down, and you can see speed stays positive. If it was velocity, then it will go down. Okay, then it is like in negative direction, it starts to increase, but at speed, it will stay positive. Okay, so here in this case, the graph will be like this. So this is the correct option. Now let's look at the next one. Pay attention, very, very important. A position time graph is a straight line inclined negatively passing through point 0, 10 and 5, -10. So how to read this thing? This is x, y. X, y. Okay, so x value is 0, y value is 10. Here, x value is 5, y value is -10. Okay, so this is very, very important. So you have to draw it. Draw the corresponding VT and AT graph. So first, let's draw XT graph. Position graph is a straight line. Okay, straight line. So it's passing through 0, 10. X is 0 and y is 10. So that's where, let's say this is 10, this is 0. Okay, so here you can see at this point, this is 0, 10. Okay, and then x value is becoming 5 and the y value is -10. Okay, so here you have to check, this is -10. So the graph will somewhat look like this. Let me draw it once again. So this is how it will gonna look like. This is the second point. You have to club these 2 points. Okay, so this will be the XT graph. Let me draw with a straight line. Okay, so that will be the XT graph. Now we have to draw the corresponding VT graph. So here you can see clearly the slope is negative. Correct? Slope is negative. So this is very, very important. We have to check this one, how this will gonna happen. Now here you can see this is total displacement, how much is happening, and then total time, how much it is, and then we have to find it. Okay, so that this is very, very important. Total displacement upon total time will give me the velocity change. Okay, look here. If I want to draw here, it's coming out to be constant. Okay, the slope is constant. So that means velocity is staying constant. Okay, Slope is constant. Slope of ST graph constant. And is it positive or negative? It will be negative. Okay. So this is very, very important. Now, what is total displacement in this case? Final minus initial. So here total displacement will be, you can see this is final, this is initial. So minus 10, minus 10. Okay. X2, X2 minus X1. Okay. Final minus initial divided by time 5 minus 0. So this will give me the velocity. So that will be minus 20 upon 5. That will be equal to minus 4 meter per second. So this will be the velocity. And you want to see how the graph will gonna look like. It's a constant. Then we can write here. We can draw here once again. Minus 4 meter per second. Okay. So pay attention. Very, very important. I will draw for you. Velocity is not changing. Velocity is not changing. And it's negative. So let's say this is V T and this is minus 4. So this is how it will gonna look like, the velocity time graph. Okay. So till 5 seconds we can draw here. So that's how it will gonna look like. Now here you can see this is VT graph. Now slope of VT graph gives me what? Gives me acceleration. And in this case you can see the slope is 0. Slope is 0. So that means acceleration will be 0. So it will be a straight line. It will gonna look like this. A, just a straight line. No value. Okay. No value. 0. So that's how it will gonna look like. So let's see how it is. So here you can see the graphs. Look here. So it started from, they have taken the origin in the middle. Okay. That's how you also can draw. It's up to you. It's the same thing. Okay. You can see 10 minus 10. Correct. And you can see it's passing here somewhere between 2.5. Okay. And then again, it's reaching 5 seconds. So you can see that's the graph. Okay. Now for velocity, you can see it's minus 4. That's how it is constant. And for acceleration, it is also 0, you can see. Okay. And here you can see it's negative, it's positive. So that's the correct answer here. Now you can take the screenshot of this one and you can try yourself. Okay. And in next class, I'll be showing you the solution for this. Okay. Take the screenshot, everyone. Very, very important. It's similar to the previous one. Okay. Little bit twist. And we'll try this one in the next class. I'll give you the solution. Okay. So that's how we need to solve it. Just like this one. Okay. XT graph is given. Find the VT and AT graph. And here we did that, right? Here the velocity was minus 4. Here also you can see 10 minus 10. Okay. Here don't get confused that, sir, how this is graph becoming. Because he has taken the 0 here. Getting it? It's the same graph. Okay. If I draw this way, this is 0. That's how the graph will gonna look like. Okay. This is minus 10. 10. This is 5. This is 2.5. Okay, it's the same thing. Similarly, he directly wrote negative coordinates. The 0 will be somewhere here. Okay, the origin for this one. It's the same thing. Doesn't matter. It's just don't get confused. There are different ways to represent, but the value should come same. The graph should look like same. Okay. Now, similarly, the acceleration was 0. That's what we draw. Acceleration was 0. And that's what we draw here also. Acceleration was 0. Okay. So take the screenshot of this one. Okay. And I hope you have enjoyed the session. Let's have a recap of the last one. So what are the key points? The slope of ST graph gives velocity. What is this ST? Displacement versus time graph. Displacement versus time graph. Similarly, the slope of VT graph gives us acceleration. VT graph का slope acceleration देता है, ST graph का slope velocity देता है. The area under VT graph gives us total displacement. The displacement can be positive, negative. अगर दोनों है ग्राफ में तो दोनों को ऐड करना होगा with sign. ऊपर है ग्राफ के तो पॉजिटिव, नीचे है ओरिजिन लाइन के तो नेगेटिव. ठीक है, तो दोनों को ऐड करेंगे तो फाइनल आ जाएगा। देन एरिया अंडर 80 ग्राफ गिव्स अस चेंज इन वेलोसिटी। तो एरिया जो 80 ग्राफ का होता है वो चेंज बताता है किसमें, वेलोसिटी में कितना चेंज आया। एक्सेलरेशन क्या करता है, वेलोसिटी को चेंज करता है, राइट। सो दैट्स हाउ it happens. You find the area. Okay, if it has above and below, you have to do the same thing just like we do for the VT graph. Okay, so now I hope you have enjoyed this session. This was basically the JEE foundation for grade 8 and 9, and also if you are in 11 12, these sessions will gonna be helpful. Okay, now this was just a trailer, and if you have enjoyed, I have a full picture for you. That is basically the JEE foundation course that we are launching from 2nd of June 2025. Okay, so this coming June 2nd, we'll be starting launching a batch for IIT Foundation. If you are in grade 9, 10, 11, 12, this is for you. Okay, now you must be wondering, sir, why should I start now if I'm in grade 8 or grade 9 or grade 10? I'll do it in 11, 12. I'll tell you the importance of why you need to start early. अगर आप 8th स्टैंडर्ड में हैं तो आपके पास 5 साल है प्रिपेयर करने के। अगर आप 9th में तो आपके पास 4, अगर आप 10th में तो 3। गेटिंग इट? सो यू कैन मैनेज द टाइम बेटर. You will have more time to do the same things if you go in 11 12th. So you will have a kickstart already ahead of the people who are just starting in 11th. So your pressure will be less. Okay, so this is very, very important. Second, we have huge competition in India. Population is huge, so we need to start early. We need to prepare for this competition. Our mindset, environment, everything should be ready for us, correct? And if you study for IIT, if you prepare for IIT, because here you will be studying the concepts in depth, so you will develop this critical thinking. You have to think deeply for every question, create a picture. And lastly, at SISYA class already there are toppers studying all over India. You will feel the competition of it. Okay, so that's also very, very important, that feeling the competition. एक होता है competition है, but एक feel करना, अपने आप को prepare करना. That's also an environment we need to have. Okay, okay, sir, I'll start early, but who will gonna teach me? Obviously, it is prepared by IITians, so IITians will be teaching you. The people who have already cracked IIT JEE मेंस एंड एडवांस एग्जाम, तो जिन्होंने ये एग्जाम क्रैक किया हुआ है वो ही आपको गाइड करेंगे, तो इसमें फायदा होगा ना. इट्स लॉजिक. अगर मैंने IIT एग्जाम क्रैक किया हुआ है, आई हैव बेटर अंडरस्टैंडिंग व्हाट ऑल प्रॉब्लम्स आई एम गोना फेस, व्हाट ऑल थिंग्स, challenges my students will gonna face, and accordingly I will help you. Okay, now IITians will be teaching you, and where they gonna teach you? Now this was on a YouTube, but at SISYA we have our own live classroom. Okay, and they will be teaching you the JEE level syllabus. Okay, from basics to JEE, where at our app, which is SISYA app, where live classes will be happening on physics, chemistry, maths. It's starting from 2nd of June, and the timing will be 6 p.m. to 7 p.m. every day, Monday to Saturday. We'll be doing some quizzes also, and after studying, once you do quiz, we will also be seeing the live ranking. Okay, very, very important. इससे क्या होगा, आप कंपटीशन फील करेंगे, एंड यू कैन ऑल्सो ट्रैक योर प्रोग्रेस की कहाँ पे मैं वीक हूँ, कहाँ पे मैं स्ट्रांग हूँ. अगर आप वीक है तो आपको पता चलेगा कि किस पे मेरे को ज्यादा फोकस करना है. ठीक है, सो आफ्टर स्टडिंग आपको कुछ डाउट्स भी आएंगे. गेटिंग इट? So that will be cleared through our quad core support through AI and mentor teacher. So our system have 24/7 doubt support. 24 घंटे सातों दिन ये AI अवेलेबल रहेगा. इट्स अनलिमिटेड. इट्स नॉट लाइक आप 5 क्वेश्चन पूछने के बाद ये आपको बोल देगा कि कल आना 4 बजे. नहीं, दैट विल नॉट बी द केस. लेट्स से आप रात को 2 बजे पढ़ाई कर रहे हैं और आपको डाउट आ रहे हैं, आप किसी को मेंटर टीचर या टीचर को उठा नहीं सकते हैं, राइट? एंड यू विल थिंक कि मैं अगले दिन डाउट क्लैरिफिकेशन कर लूंगा. नहीं, what you need to do, you need to just go to the SISYA app and get it clarified so that you don't have hindrance in the studies. And then after that you also gonna have one-on-one mentor session. So we have mentor teacher who have expertise in this thing, and if you still want to clear doubts through master teacher, they will also gonna help you. ठीक है, और इसमें हम लोग AI और मेंटर टीचर का भी कोलैब करते हैं कि आपकी स्टडी प्लान बनाते हैं कि कैसे आप इस वीक पॉइंट को ओवरकम कर सकते हैं. ठीक है, अब पढ़ाई कर ली, डाउट क्लैरिफिकेशन कर लिया, अब क्या बचा? आपका सेल्फ स्टडी करना। सेल्फ स्टडी आईआईटी के लिए प्रिपरेशन के लिए बहुत इंपॉर्टेंट है। तो हम लोग आपको हर सेशन के बाद डेली प्रैक्टिस प्रॉब्लम देंगे। आपका स्टडी मटेरियल रहेगा, स्टडी मटेरियल डिजिटल फॉर्म में रहेगा, यू कैन डाउनलोड इट एंड यू विल ऑल्सो गोना हैव वर्कशीट। वर्कशीट्स में क्या होगा? लेवल 1, लेवल 2, लेवल 3 के क्वेश्चन होंगे। लेवल 1 क्या होगा? सब्जेक्टिव इजी, लेवल 2 सब्जेक्टिव हार्ड, लेवल 3 विल बी मल्टीपल चॉइस क्वेश्चन जिसमें सिंगल करेक्ट, मल्टी करेक्ट, असर्शन, रीजन, कॉम्प्रिहेंशन, ये सब रहेंगे जो मेंस और एडवांस में आते हैं। अब प्रैक्टिस भी कर ली, पढ़ाई भी कर ली, डाउट भी क्लियर हो गया, अब क्या? अब आपको टेस्ट भी तो करना है, राइट? सो वी विल बी कंडक्टिंग टेस्ट, बाई वीकली टेस्ट कंडक्ट करेंगे, आपको रिजल्ट भी मिलेगा, आपको रैंकिंग भी मिलेगी, आपको पता रहेगा कि ऑल ओवर इंडिया आपका रैंक कहाँ है। ये नहीं कि आप 50 बच्चों में अपनी रैंक ढूंढ रहे हैं अपनी क्लास में, स्कूल में, नहीं। That's not the competition. Real competition is all across India. So here the students are studying all over India. So you will also see where you stand. So through bi-weekly test, you will see that, and we'll also be conducting test series. ठीक है? जिससे not just SISYA students all over India और सारे बच्चे भी देंगे। ठीक है? So this will also gonna give you a better ranking. Okay. Now, sir, सब कुछ आपने बता दिया, अब प्राइस क्या है इसका? Now, if you check the price, original price, if you are in 8th standard, it will be 90,000. If you are in 9th standard, you want to buy for 9th standard, it will be 90,000. If you are in 10th standard, you want to buy for 10th only, it will be 90,000. And if you are in want to buy the multi-year package, then the price gets add on. For if you are in 9th, you want to buy for 9, 10th, this will be the price. And if you want to buy for 10th, 11th, 12th, sorry, this one is sold out. Okay, लास्ट वाला जो है ये सोल्ड आउट हो चुका है। ठीक है, अब आप बोलेंगे सर दिस प्राइस इज टू हाई, इट्स सेम एज अदर इंस्टीट्यूट्स व्हाट दे आर प्रोवाइडिंग, बट लेट मी टेल यू स्टूडेंट्स, डोंट वरी, एट सिस्या वी बिलीव इन अफोर्डेबल क्वालिटी एजुकेशन। जो क्वालिटी एजुकेशन होनी चाहिए वो अफोर्डेबल होनी चाहिए, बिकॉज दैट्स हाउ many students can get this thing and they have a better chance in competing with other students. Okay, so at SISYA we believe that, and that's why I'm giving you a special offer जहां पे price काफी सारा reduce हो चुका है, and you can see the final price. If you're in 8th standard, it's just 15,000 for one complete year. If you're in 9th standard, it's just 16,000, and if you're in 10th standard, it's just 17,000. And if you purchase for multi-year, it's again better option for you. It will be just for 3 years complete package, 40,000, 3 साल के लिए। सोचिए, that much low price we are providing you, that to IITians teacher जिन्होंने ऑलरेडी जेई का एग्जाम क्रैक किया है, वही आपको गाइड करेंगे। इतना मस्त नहीं रहेगा? If you are in 9th standard, then you can buy 9th and 10th also. The price will be 31,000. The last one is already sold out. You can't purchase this thing. The batch is already filled. Okay. Total number of students were 30 out of 30 already filled. And for 8th standard, our 80% seats are over. For 9th standard, 75% seats are over. For 10th, 90% seats are over. So if you want to enroll, let me tell you, the link is there in the description box. You can click on that link and get yourself enrolled at this price only. Okay. यहाँ पे आपको सब कुछ मिलेगा, टीचर से लेके, प्रैक्टिस से लेके, डाउट क्लैरिफिकेशन से लेके, टेस्ट तक सारी कंप्लीट जर्नी आपको रहेगी, जिससे आपको ओवरवेलमिंग रिस्पॉन्स और अंडरस्टैंडिंग मिलेगी। ठीक है, आपको एंग्जाइटी जो है ना प्रिपरेशन की, वो एकदम खत्म हो जाएगी। ठीक है, सो आई होप दिस इज क्लियर एंड आई होप यू हैव एंजॉयड द सेशन. If you enjoyed it, you can also download the SISYA app on our Play Store and you can watch the demo sessions also. We have long-term courses there also. So if you like this session, you can like, share, and subscribe. And don't forget, the link to enroll in the foundation course is there in the description. So go and click and check and get yourself enrolled. So take care. Bye bye. Thank you.